Balancing chemical equations. Objectives. Write a balanced chemical equation for a reaction. Chemical equation. A chemical equation is a representation of a chemical reaction that uses symbols to show the relationship between the reactants and products. Here we have hydrogen reacting with oxygen to produce water. The reactants are written on the left side of the arrow, while the products are written on the right side. The arrow can be expressed as yield. Letters in parentheses are used to denote the state: S solid, L liquid, G gas, and AQ aqueous, means dissolved in water. In a balanced equation, there are whole numbers called coefficients in front of the formulas. The coefficients are in the smallest whole number ratios. In this example, we have 2 in front of the hydrogen, which means that there are 2 diatomic molecules of hydrogen present for a total of 4 atoms. There is a 1 in front of the oxygen, but it is understood, so there's 1 molecule of oxygen, while there's a 2 in front of the water, indicating that there are 2 molecules of water present. The same number of atoms present in the reactants and products illustrate the law of conservation of mass, that matter cannot be created or destroyed in a chemical reaction. Balancing a chemical equation. First, we need to write an equation using the correct formulas of the reactants and products. Here we have Na solid plus Cl2 gas producing NaCl solid. Chlorine is not written as Cl alone. It is written as Cl2 because chlorine exists as a diatomic molecule. The formulas must be correct. Next, we count the number of atoms of each element in the reactants and products. We have 1 sodium and 2 chlorine atoms on the reactant side, while on the product side we have 1 sodium and 1 chlorine. Next, we use coefficients to balance each element. Since we have 2 chlorine on the reactant, the left side, we also need to have 2 chlorine on the product side. We can only do this by adding a coefficient in front of NaCl. Subscripts and diatomic molecules or chemical formulas cannot be changed. Only the coefficients can be changed. So, we add a 2 in front of the NaCl, which produces 2 NaCl molecule on the product side. Therefore, we have 2 sodium atoms and 2 chlorine atoms. Now looking at our atoms, we have more sodium on the product side than on the reactant side. Now we need to go back to the reactant side and change the coefficient in front of Na. We can add a 2 in front of Na, which now have 2 sodium atoms on the reactant side. And the number of atoms on the reactant side and the product side are equal, and our balanced equation is 2Na plus Cl2 produces 2 NaCl. Balancing a chemical equation. Practice. Here we have aluminum plus bromine producing aluminum bromide. Identifying the number of atoms on the reactant side, we have 1 aluminum, 2 bromine, while on the product side we have 1 aluminum and 3 bromine. Since the bromine does not equal, we go back to the reactant side and we try to change it from 2 to another number. If we add a coefficient of 2, now we have 2 diatomic molecules of bromine, which gives us 4 atoms of bromine. However, on the product side, we only have 3 atoms of bromine. So now we go back to the product side and we add a 2 in front of AlBr3, changing bromine to 6, while aluminum changes to 2. Now we have 6 bromine on the product side, while on the reactant side we only have 4. Coming back to the reactant side, we change the 2 to 3. Now we have 6 atoms of bromine. Additionally, we also observe that aluminum, there are 2 atoms on the product side, while there's only 1 atom on the reactant side. So if we add a coefficient of 2 in front of the aluminum on the reactant side, we have an equal amount of atoms on the reactant and product side. So our formula is 2Al plus 3Br producing 2AlBr3. Balancing a chemical equation with polyatomic ions. First, we need to write the equation using the correct formulas of the reactants and products. Next, we need to count the number of atoms of each element present. However, we do not separate the polyatomic ions if they're present on both sides of the equation. In this example, we have one barium on the left, two chlorines on the left, one sodium on the left, and we have a polyatomic ion OH. So we count the OH together. We have one on the left. On the product side, we have one barium, one chlorine, one sodium, and two hydroxide polyatomic ion. So next, we need to balance our equation. We have two chlorine on the left, one on the right. Therefore, we add a coefficient of 2 in front of NaCl, which changes the number of sodium to 2 and the number of chlorine to 2. Now we have more sodium on the right than the left. So now we go back to the left side and we add a coefficient of 2 in front of NaOH, which changes the number of sodium to 2, and it also changes the number of OH to 2. Looking at our equation, we have equal number of atoms on the reactant side and product side. Therefore, this is our balanced equation. Combustion reactions. Combustion reactions are unique where we can use a few tips. First, we must understand to balance hydrogen second to last and oxygen last. Here we have one carbon on the reactant side, 4 hydrogen, and 2 oxygen. While on the product side, we have 1 carbon, 2 hydrogen, and we must be careful to count all the oxygen atoms. We have oxygen present in both carbon dioxide and water. So counting both set of oxygen, we have 2 from carbon dioxide and 1 from water, a total of 3. So we need to balance our carbon. We have 1 on the left, 1 on the right. The carbons are good. Next, we balance our hydrogen. We have 4 on the left, but only 2 on the right. So we add a coefficient of 2 in front of the water, which changes the number of hydrogen to 4, while the number of oxygen also changes. We have 2 from water and 2 from carbon dioxide for a total of 4. Now we need to go back to our reactant site to balance our oxygen. We only have 2, so we put a coefficient of 2 in front of our oxygen, producing 4 atoms. Here we have our balance equation. CH4 plus 2 oxygen produces carbon dioxide plus 2 water molecule. Coefficients that are fractions. Here we have C2H6 plus O2 producing CO2 and H2O. Key, balance the hydrogen second to last and the oxygen last. We have 2 carbons, 6 hydrogen, and 2 oxygen. On the product side, we have 1 carbon, 2 hydrogen, and we need to count all the atoms of oxygen. We have 2 from carbon dioxide and 1 from water, a total of 3. So we balance our carbon first. We have 2 on the reactant side, but only 1 on the product side. So we add a coefficient of 2 in front of carbon dioxide, which changes the number of carbon to 2. However, the number of oxygen also changes. We now have 4 from the carbon dioxide and 1 from the water. So we have a total of 5. Next, we balance our hydrogen. We have 6 on the reactant side, but only 2 on the product side. So we put a coefficient of 3 in front of the water, and now we have 6 atoms of hydrogen on the product side. However, the number of oxygen also changes again. So now we have 4 from the carbon dioxide and 3 from the water for a total of 7. Now, balancing the oxygen last. We have only 2 oxygen on the reactant side. We add a coefficient of 3.5. 3.5 multiplied by 2 gives us 7, which balances our equation. However, coefficients can only be written as whole numbers. If there's a fraction of a half of 0.5 in a decimal format of oxygen, we can multiply all the coefficients by 2. The coefficient in front of C2H6 is a 1. It is understood. If we have to multiply that by 2, we have 2. The 3.5 in front of the oxygen becomes 7. The 2 in front of the carbon dioxide becomes 4, and the 3 in front of the water becomes 6. Rewriting our formula, we have 2 molecules of C2H6 plus 7 diatomic molecules of oxygen rather, producing 4 molecules of carbon dioxide and 6 molecules of water, which is a balanced equation.